8-3. So we are still hypothesis testing. For the difference in population means, this time it's for dependent samples. Okay, the last two sections, they were independent samples. Independent meant that there was no overlap. You didn't have the same car in both crash tests. You didn't have the same kind of tire in both braking tests. So there was no overlap. And then we did big samples, small samples. Today, we're doing dependent samples, kind of like a before and after. You've got your one group of people, you test them before something, the exact same people you test after something. So it's a before and after. So dependent means you've got the exact same people in your two groups, or items, or whatever they are. So, all the same. So it's paired. So dependent means that, let's see, how did I say? Each member of one sample corresponds to a member of the other sample, paired or matched. So each member in group 1 is also in group 2. So we call this paired data. Okay, for dependent samples, it doesn't matter how big the samples are, it's always going to be a t-test. So this will always be a t-test, so we'll be using the t-values. So that means both, it means your population has to be normally distributed. I don't know. I don't know if I was that cruel or not. Okay. Okay. The test, I should say the sample test statistic is D bar. Normally it's been the sample mean, X bar. It's the average of whatever they were looking at for each sample, and we took the difference there. Well, here it's D bar, and what you're going to do to find D bar first is you're going to sum up each X value, like it's before minus after. I'll use before and after, B and A. So you find the difference for each person, before and after, add up all the differences, and then divide by how many you had. So you're finding the average difference for your sample. Then you've got to turn D bar into a t-value to see where it lands on your graph. So the formula for that, the t-value for D bar is D bar minus the population difference divided by the standard deviation of the differences over the square root of the sample size. Okay. Are you ready? I need my book for my examples. Just examples left. I think we'll do 2 by hand, and then 1. Well, once we have the t-value, we'll have our graph with the shaded region. We'll find the t's and see if it lands in the shaded or not, just like we've been doing. So I'm going to do 2 by hand, because sometimes they tell you what d bar is, and sometimes they make you find d bar. So we'll go through that. What page am I on here? 2, 3. Well, it's different. It stands for the difference. So let's see what we've got here. So example 1. So the golf club manufacturer claims that golfers can lower their scores by using the manufacturer's newly designed clubs. So their claim is that the scores will be lower if you use our golf clubs. Eight golfers are randomly selected, and each is asked to give his or her most recent score with their own golf clubs. Then they go out and use the new golf club and get their score again. So you've got the same 8 people before the new club and after the new club. So we'll go before, which is using their own clubs. And then we'll go with the after, is going to be using the new club. New clubs. So the scores are: person 1 shot an 89, came back with an 83. Person 2 had an 84, came back with an 83. A 96, came back with a 92. 82, came back with an 84. 74, came back with a 76. A 92, came back with a 91. 85, came back with an 80. And 91, shot a 91. So we're going to check and see with these 8 people if there's enough to verify that these clubs are making the scores lower. All right. So what else do we need to know? We're going to test this at alpha equals 0.10. Assume golf scores are normally distributed. Okay. So it's rewrite the claim. Yeah. 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 So, rewriting the claim, what are they saying about the mean before versus the mean after? Greater than? Okay, greater than. And we want to write it as a difference, just like before, so we'll subtract the mean after. So mean before minus mean after is greater than 0. That makes that the ha. And then the book, for some reason, why they didn't just leave it the same, they changed this to mu d, the mean difference. So if you want to, this is the mu of the difference, the mu of the difference. I don't care, you can leave it that way, but our formula, see how it has mu d here? That's just mu before minus mu after. So, okay, What tail test are we doing? Right tail test. .10 shaded, .90 not. This was a small sample with 8, but it's always going to be a t-score here. You're never going to use your inv norm. So our degrees of freedom, what do you think here? What's your best guess on degrees of freedom? N minus 1 or N minus 2? Nope. You had a 50-50. It's one group that we're using twice, so it still is just one sample. So the degrees of freedom, probably should have wrote that at the beginning here. DF equals N minus 1. Because we've got the same number of people in the first sample as the second sample because they're the same people. So when we look up our critical T value, we had 8 golfers. 1, 2, 3, 4, 5, 6, 7, 8. So we're going to have 7 degrees of freedom, a 1 tail with .10, 1.415. And it is positive. And what we need to do first is find D bar. This is the extra step in this one. I don't know what the average difference is. They didn't tell it to me. So we've got to find D bar first. And we're going to use our lists to do this. So I'll write out the steps in the notes for you. But it's kind of just following that formula. So to find D bar using lists, you can see I want their before scores minus their after scores. So we're going to put the befores into list 1. Put the after into list 2. Then if you look at the formula, what's my next step? After I've got the befores in list 1 and the afters in list 2, what am I going to do? List 1 minus list 2 probably over in list 3. So list 3 is going to be list 1 minus list 2. Okay, so I'll have all of the differences. Then what do I want to do according to the formula? Add them all up. So we're going to sum up list 3. And then the last thing we want to do is divide by how many I had. So it'll be, the last thing will be the sum divided by the number. That will give us D bar. Once I have D bar, then I'm going to do the by hand formula for the T. All right, so let's practice it. Where's mine? So you need 3 lists cleared out. Stat. All right. Oops. You remember where everything's at? That's under list. You got to go to second list, over to math. Divided by 8 we had? 1.625. So our D bar came out 1.625. And now we've just got to turn that into a t-value to see where it lands on our graph. So to turn 1.625 into a t, we take 1.625. The difference from the whole has a 0 in it. Oh, we need the standard deviation of our difference list, that SD. So we need to run one var stats on list 3. I wonder if it'll give us our d bar right there. I bet it will. So let's go stat, calc, one var stats on list 3. Oh, look at right there's the x bar is our d bar. And then our s is 3.07 over the square root of 8. So really, we could fix this up. Once we have list 3, we could just run one var stats. And the x bar is your d bar. So after you've got L3, just run one var stats, because you need the mean and the standard deviation anyway to go into your formula. And now it's calculator work. You need parentheses around the denominator. So if we've got 1.497, where does that put us? In the shaded, so we're going to reject. Null. Claim is true. Their golf clubs are good. Let's see, do I give you any where they... Yeah. Sometimes they just give you everything without the data. So like example 2, we'll do it by hand. Let me go claim the average difference less than 0. Alpha is 0.5. D bar is 10. SD is 1.5. N equals 10. Test the claim. Okay, so no lists for me to do. They've done everything for me. They put it in the list. They ran the one var stats. Here it is. And they wrote the claim for me. And remember, the mu d is your before minus after. Okay, so the claim is the ha. The whole will be greater than or equal to 0. And now we're ready to jump right into what tail test are we doing? Left tail, because of the less than. It's got a 0.05. This is a 0 in the middle. We've got to find this t-value from the table. How many degrees of freedom we got going on here? 9, because of the 10, so 1 less. We got 9 degrees of freedom. We've got a 1 tail, what was it, 0.5? 0.5, 9, 1.833, negative 1.833. Now we don't have to do find d bar. They gave it to me, so we can jump right into the converting d bar into a t-score to see where it lands. So they saved us a lot of work by just giving us everything right up front. So the t-score for d bar, according to our formula, is D bar, which is 10, minus the difference from the hoe. The hoe has a 0 in it. The standard deviation was given as 1.5. Sample size was 10. So a little bit quicker when they give you everything. $21.08. Is that what you guys got? Yeah. That's a big one. Okay. We're not even going in the right direction. Oh gosh, did I write that all down right? 11. 21, yep. Negative 1.833, yep. We got it. So we are going to fail to reject the hoe. Usually it doesn't go the opposite way like that, but this one did. That would make the claim neat. Okay, the program for this one. The program is a t-test, just a regular, not two sample t-test. It's a t-test on your list 3 after you found the common difference. So it will be a t-test, not two sample. On your list 3. So you're going to want to run that one var stats on list 3 so that it throws everything into the program. Let's just go with the data that we've got. We don't have to type a new one in. Let's see what p-value we get. So with the golfers, you would do the same thing. You would put your before in list 1, your after in list 2, subtract them to get list 3. Quit and run one var stats on list 3, and I think I already did that. One var stats on list 3. Because when you run one var stats, I think it kicks all this information into the programs. Now let's go to t-test. We want the regular old one sample t-test. If you use stats, let's see, mu 0, that's from the claim. What's our claim though? What was in the hoe? What number? 0. X bar is 1.625, that's our D bar. The S is already transferred in, there were 8. What was our Haas sign back in example 1? Was it greater than? That's the end one. Calculate. And we get a P of 0.089. And how does that compare to the alpha? Was our alpha 10%? So P is smaller than alpha. So we reject the hoe. Claim true. Same result. And then number 4. The confidence interval here for mean before minus mean after is just your t-int. On list 3. So if we run that, stat, test, t-interval, oh, let's go 95%. Everything's in there, and you just go down and calculate. Okay, hold on while I finish up the assignment here. Okay, that sounds good. All right, we've got 8-3. Page, see if I can get the right page this time. Page 395. Four through 24 even. We gotta see which ones we want to do by hand here. I didn't write it down. 8, 3, 4. Classify independent, dependent. Okay, that's easy. 10. Oh, they don't start till over here. 12, 14. Let's see. I picked 20, 22, 18. The end of it to be by program. 18 to 24 program. And then the rest of them are by hand.